Okay, before we end lesson 1, we're gonna look at a few key definitions. I've already talked about this, but I wanna put it all next to each other so you get a good grasp of the difference between supervised, unsupervised learning, as well as reinforcement learning. We're mainly dealing with supervised learning. What does supervised learning mean? That means that you give the computer the inputs, we call it also the features, xi, but we also give the computer the outcome, the labels yi. And then the computer will look at finding a transformation that maps the xi to the yi, and that will be your model. This model now you're going to use to make predictions on unseen data, data that was not part of the training sample data. So it's very clear here, you teach the computer by example. And the inputs and the outputs, these are your examples. We looked at classification problem. For example, you have two features, x1, x2, and you have a certain class of data that is y equal to 1, and another class of data y equals to 0. And you have a decision boundary that actually splits the data. And our task will be to find this decision boundary. That will be discussed in the majority of the classification problems. So if you have supervised learning, you guessed it right, you will have also unsupervised learning. Unsupervised learning, you don't give the computer the outcomes. You just feed it with inputs, data, and you ask the computer to find structure in that data. Give an example here. This is, for example, a clustering algorithm. Clustering algorithm that could be k-means. K-means. So basically you tell the computer, I want 4 clusters in this data, and you give him the 4 clusters like this. Sorry, it's a computer that will decide on the clusters. So that is unsupervised learning. Supervised learning with a G. Okay, now reinforcement learning. Reinforcement learning is quite hot at this time. It's a research area, and it takes machine learning to the next level. Where in supervised learning, you teach the machine by example. In reinforcement learning, you let the machine make observations and learn from these observations. Basically, this is a structure. So you have an agent. The agent is your machine, and you want the agent to make a sequence of good decisions. What are good decisions? Well, good decisions are decisions that maximize the reward. So in this case, the data scientists need to design not only the algorithm, also needs to design the world in which the agent operates in, and it needs to design a reward structure. What is, of course, a big issue with teaching by experience? I give an example of autonomous vehicles. You cannot put an autonomous vehicle on the road, on a public road, and let it learn by experience. This would be a disaster. There will be accidents all over the place. So that means that the teaching by experience, you should be able to do it through simulation, before you actually put an agent on the field trying to observe the world. Google has, of course, DeepMind from Google. They have developed something, a reinforcement learning algorithm that is able to play Atari. So lots of this stuff to come in the next few years. All right. Next lesson, we're gonna take a look at gradient descent. It's the most widely used optimization technique. And we're also gonna take a look at how can we make gradient descent better. In lesson 2, you will need a background in calculus. You need to know what a derivative is, what a partial derivative is, what is a gradient, what is a Hessian. If you don't know all these terms, take a look at the calculus refresher. It's nicely explained over there. And we will be dealing a little bit with vectors. So Take a look at the linear algebra refresher as well. And just a final note, the course notes can still be found on GitHub under my username, M from Mario, and then my last name, Faves. See you next time.